Friends, my name is Shravant Kumar from Sri Venkateshwara College of Engineering, studying in 4th SEM Aryabhatta section. Today my topic is quicksort and time complexity of derivation. Introduction to quicksort. Quicksort is a popular sorting algorithm. It follows the divide and conquer approach. It has time complexity of 0 n log n on average. Step 1. Determine a pivot. Take an array and select the pivot element. Shift the pointer to the pointer to find a value greater than the pivot. Step 3. Shift the right pointer to find a value less than the pivot. Step 4. Swap values at the pointer. Step 5. Repeat the above steps until two pointers meet or across. How to quicksort works. Quicksort selects a pivot element from the array. It partitions the array into two subarrays, elements smaller than the pivot and elements greater than the pivot. The process is recursively applied to the two subarrays. Choosing the pivot element. The choice of pivot element is crucial for the efficiency of quicksort. The most common approach is to choose the last element as the pivot. Other strategies include choosing the first element or a random element. Now we take an array, we can choose the last element as the pivot element. Complexity analysis average case. In the average case, quicksort has a time complexity of 0, n log n. Partition steps takes 0 times. The recursive calls are made on subarrays of size approximately n by 2. Quicksort. Worst case complexity. Worst case running time. Assume first element is chosen as a pivot. Assume array already in order. Recursion. Partition splits array into two subarrays. One subarray of size 0, the other subarray of size n-1. Quicksort each subarray. Depth of recursion tree. Number of access per partition 0n. Complexity analysis of worst case. In the worst case, quicksort has a time complexity of 0 n power 2. This occurs when the pivot is consistently chosen as a smallest or largest element. This can be mitigated by using randomized or median of 3 pivot selections. The graph represents the time complexity. Input size versus CPU operations. Complexity analysis best case. In the best case, quicksort has a time complexity of n log n. This occurs when the pivot is always the median of the array. However, finding the exact median is not practical in most cases. The right side graph gives the best case in input size versus running time complexity in terms of big O. Optimization of quicksort. Several optimizations can be applied to improve the performance of quicksort. These include using insertion sort for small subarrays and median of 3 pivot selections, and using a cutoff for switching to different sorting algorithm. These optimizations aim to reduce the number of recursive calls and improve the overall efficiency. The position of elements are after each call of partition algorithm. The right side gives the position of elements after each call of partition algorithm. Space complexity of quicksort. Quicksort has a space complexity of O log n in average case. This is because the recursive calls consume additional memory on the call stack. However, the overall space usage is relatively small compared to the input size. Comparison with other sorting algorithms. Quicksort is often preferred over other sorting algorithms like merge sort and heap sort. It is better average case performance and is often faster in practice. However, it is not stable sorting algorithm. Conclusion. Quicksort is widely used sorting algorithm known for its efficiency. It has an average case time complexity of O n log n and worst case complexity of O n power 2. By using various optimizations, its performance can further improve. The right side gives you quicksort algorithm. We take an array and divide it into two subarrays. In main array, we will select the last element as a pivot element, and if the element as the greater than pivot element, swap to left, and less than pivot element and swap to right. Thank you.